Hello statistics student, this is a second video of chapter 2.5 and 2.6 measure of center and skewness. In the last video we talked about the four symbol or the four numbers or summaries that you can use to describe the center of the data. That means what is one number that is most representative of all the data, where data cluster around. So there's four summaries. You can use mean, median, mode, and mid-range. And median is very important. It's so important that it has this two symbols. If it is from sample data, we call it X bar. If it is from population data, we call it mu. And very often we would use X bar to estimate the mu if your sample is representative. But if the sample is not representative, you cannot. The second fact that is very important is extreme data can affect a mean. Extreme data, if there's a extremely high or extremely low data, the mean follow it. The mean will be distorted towards it, and we call it resistant. So that's the main thing. Now we are going into how to calculate the four numbers, and primarily we use StatDis. And for mode, because StatDis does not give us mode, it can only give us mean, median, and mid-range. So there is another calculator called calculator soup that you can use to find mode. Theoretically, the Excel and also Google Sheets can find mode also, but they only find one. They cannot find multiple. The other thing we should mention before we do the calculation is a round-off rule. Most of these packages, when they find the mean and median and mid-range, they will round to what are all the decimal places that they can show you. Sometimes 5 or 10 decimal places, but the round-off rule is you just want one more than the original data. If you have a whole number, you would do a whole number plus 1, that means one place. If your original data has 2 decimal places, then you round 3 decimal places for the mean. So let's do an example to illustrate this. So this is an example. They say find mean, median, mid-range, and mode for length of boat parked in a marina. So they collect the length of the boat in feet parked in the marina. We want to find this number. So this number I have entered into a data file here. Boat length, video data. So if you want to, you can look at video data and copy. Just highlight it without the title and then go to StatDis. So open a browser and you will see here StatDis. I have some old data, so I'm going to clear them up, or actually just start from scratch. So you go to the first column and you do Control V. Use Control V to paste it in. Just paste does not work. You have to use Control V. For PC, I don't know, for Macintosh, maybe it work. And then you would say, I'm going to calculate mean, mode, and median. It would be under Explore Data. Then the sample, it seems like the data goes away, but actually it's still here. So if you do Sample Editor, you can see it's still here. My data is in column 1, and I click Evaluate. The mean, median, and mode will show up. Okay, 27.3333, but we don't want to calculate all those. We just say 27.3, 27, and 28. They're actually pretty close to each other. Right? Go back to my notes. So I would say, yeah, I already did that. It's 27. The median is 27.3 for the mean. I do not want to write 333 because I only need one places. And this is 27. The mid-range is 28 from StatDis. Now, StatDis does not show mode. So what is the best way to find mode? Okay, I'm going to show you two methods. So one is to sort this data in order. Sort data. Under data 2, you say I'm going to sort one column, which is column 1, and then sort. So this is sorted in order. And then what you can do is the data that are the same number would cluster around, right? So you can see, oh, I have 1, 2, 3, 325. I have 327. they are the most frequent one. All the others are just single number or double number. 20 only has 2. So the mode would be both 25 and 27. So that is one way. So that's how my number is 25 and 27. If this is a big data set and you do not want to go through the list like that, you can go to calculator soup. Paste your data just like before. You can just paste. Okay, it would be in a column, and then you do calculate. So it would show 27. It would show mean and median too, and then they have actually this. And then the mode is 25, 27. So it's a little more convenient, but it's not as, you have to have another tool. So that's how you do it. The second question is, can I use this mean? This is an X bar because it's from a sample, to estimate mean length of all boats. This is one mean, which is X bar, right? This is what we calculate. Can I use it to say, well, maybe all the boats in all marina is 27.3 feet long? Can I do that? I would say no, because this mean is from a sample from one marina only. Is not from everyone. It's not a random sample. If you choose this marina because you do a random sampling, maybe you can say it. But if you base on your data on one location, it's actually not a good idea. So not a random sample. Not a random sample. So it is not representative. So X bar cannot estimate mu. So get used to using this symbol, X bar and mu. Okay. Second example is comparing the size of mean and median. Okay, compare the size. So I have these data that I want to calculate, the 4 numbers. So practice one more time. So the data is in here. So I just highlight it, copy it. And then I go to the browser where I have set this. I can just paste in column 2, right? Control V. And I say I'm going to choose column 2 and evaluate. So all this will go away. Oh, you can see a rough estimation of how this data look like. It look like a skew data, right? The mean is 15.08333. But if I want to round to 1 decimal place, it will be 15.1, right? And then median is 12.5, mid-range is 16.5. They're already in one place. So I'll do that. So we'll go back here and write down 15.1. Okay, it's not 0.888. You don't need that many places. Median is 12.5. Mode we don't know. Mid-range is 16.5. What is the mode? You can actually, because it's such a small data set, you can say 1, 2, 3, 4, 12 occur the most, so it should be 12. But for just for illustration purpose, I can just do calculator soup again. See if it is correct. So take out this old data and then paste my data in and calculate. So you see that it is the most 12. If you're too lazy to look at the things, but they have a lot of add. Okay, get this away. So go back to ours. So they ask what is the greater number, mean and median or mode or mid-range. The mid-range seems to be the larger one, right? So this is the largest. And then if I compare these two, the mean is larger than greater than the median. No, mean is greater than the median. What does this mean? It turns out that by comparing this, we get an initial estimation as to the skewness of the data. That means where this data skews towards. we talked about it earlier, that mean seems to follow extreme data, extremely high or extremely low. So if you have a data set that is skewed, the mean is going to follow the tail. So if the mean is larger, that means data is not going to be clustered around the mean. Data is closer to the median. More data is on the low end, less data in the high end, because the mean followed the high end. So this tells us that the skewness is skewed to the right. We'll talk about that later on. So you can imagine that it is skewed to the right, which we can confirm by looking at this. Most data are on the low side. There's some high data, but they're lower frequency. Okay, a lower frequency. So by just comparing these two numbers, we can actually tell something about skewness. Of course, in a more advanced statistic class, they have other number that can measure skewness. So let's officially talk about this, and also talk about when to choose what is the best choice of center. So officially we say if the data is symmetrical where the mean is equal to the median, then we can say they are symmetrical. If the mean is smaller, then the median is larger, that means more data cluster around the median, so you have skew to the left. The other way around, if mean is larger, like the one that we just did, then more data is clustered around the median, which is a lower number, so this is skewed to the right. So you can use this relationship between mean and median to, without graphing, actually had an idea on the skewness of the data. When mean is lower, it's skewed to the left. When mean is larger, it's skewed to the right. The next thing is about best measure of center. Comparing these four numbers, which one should we use as a center? We say the mode can be used as a center if your data is a nominal data. They're not a measurement, they're just category. If there's no extreme data asymmetrical, you use the mean. Because comparing mean and median, they're exactly the same. The mean is better because it has a formula that you can process. It's easier to process statistically. If you have data that is very skewed, or you know that your data has extreme data, then the median is a better measure of center. And that explains why, in general, if we are talking about data such as income data, for income, what do you think the income data's distribution is? So if you collect a lot of people's income, most people actually earn very low hourly wage, right? Just a few $1 million people, CEO or people that own a big company. So this is the frequency. The frequency of high number of values, high income is really low, but most people has low income. So a lot of people, this is frequency, right? It's a histogram. So if you have a distribution of data like this, you do not use mean income. Okay, you would use median income to illustrate this. So you will notice that in the news or in econ news, you never hear people talk about the mean income of this country has rise or whatever. They always talks about median income or median home price. But for temperature, they might say mean temperature. So it has to do with whether extreme data exists and also the skewness of the data. So that is, and in the next video, we'll talk about how to find mean from a frequency distribution.